All right. Um, which line? So parallel lines. Again, when we're saying parallel, we are looking at the gradient. So which lines have the same gradient? Well, this one's the same. This one's also the same. However, this number here is important. It's the same as that one, so that discounts C because it's the same line, it's not a parallel line. So that means A is the parallel line. Okay. Find an equation that is parallel. So again, parallel means we're looking at -2. So that gives all of them. But we need it to go through the point 5 minus 4. So how do we do it? Sort of a bit of trial and error, I guess. You could try them all.
Y is equal to -2x plus
But you've
c.
decided D. Okay, so let's try D. So we've got if x is 5, y is -4. We could try all of them, but Toby thinks it's D. So let's have a look. So 5, no, not 5. Y is -4, so -4 equals -2 times 5 plus 6. So if that's true, which it is, it must be that one. If I tried it in a different one, it wouldn't be true.
You could just, but you don't have to do trial.
Go on, what's your way of doing it?
Well, I know it's parallel, so it has the same gradient. So
Yeah, all of them.
Yeah, but then you can't use everything, so you just write y is equal to -2x plus c, and then you can just put into that y is equal to x plus
Yeah,
c.
I mean that's probably a preferable approach, isn't it? Like actually work it out so you know you've got -2x plus c, so just put that in, don't you? So -4 is -2x. Actually, not -2x, but -2 times 5 plus something. So -4 is -10 plus something, so you know it's plus 6. So use that approach is quicker and better. Trial and error approach would have worked, but taken longer. Equation parallel to -4x plus 5 that goes to that point. So we're going to have y equals -4x plus something. Put this in. So -14 is equal to -3 times 3 plus c. So -14 is -9 plus c. So that means c is going to be... Oh, sorry, that's a 4, isn't it? Yeah. Let me write. So that should be -12, yeah. So that should be -2. So we've got y is -4x minus 2. Okay. The graph one, the equation of a line. So this time, we're not given an equation, but we need to know what the gradient is. So the gradient of this one is, so we find a point here. Here's a point I know, and then here's another point I know. So we've got rise over run, so that's up 5 across 1, which means the gradient is 5. So we've got 5x plus something. Now this one is going to be y equals 5x plus 4. But one that goes through -1, -4. Again, we're doing the same thing every time. -4, 5 times -1 plus c. It's very repetitive. So c is just 1. Add 1. So we've got y equals 5x plus 1. Okay. Let's... Number 5.
I thought we can.
Again, same approach, isn't it? So equation that is parallel. So it's just going to be y equals 3x again, plus something. Goes through 0 minus a, which is a very nice one because of the 0. So it just becomes y equals 3x minus 8. I don't have to do any thinking. This one, slightly different. So gradient of the line perpendicular to line with gradient. But this time, it's just, what's the gradient? Well, if the gradient of the line is minus 3 over 2, it's going to be positive 2 over 3. And then run it as a fraction or a decimal. Leave it as a fraction, it's just super easy. The reason is some people would do the minus 3 over 2 times whatever the gradient is equals negative 1. Remember we did that? And they would do it working out that way. It seems like a hard way to do it, but it is a possibility. But we should do our check, which is negative 3 over 2 times 2 over 3 does indeed equal negative 1, so we're good. So that's the gradient of a line that's perpendicular. Okay? So, which of the following is perpendicular to 3 over x? Well, again, 3 is the gradient, but this time we are looking for one that is negative 1 over 3, which is, this one is not a negative, so it can't be that one, so it's only this one. Okay, so this would be the correct answer. All right, and then all of these others, it's just the same repeated, only the only different step is the gradient is the negative reciprocal instead.